In this world of probability distribution, we're now going to talk about the expected value. And the expected value of a random discrete variable, or discrete random variable, is the weighted average as it is applied to each value and its theoretical probability. And we can calculate an expected value. And so let's just kind of go through this problem here. Regarding this, says Wendy entered a contest with the following prize value. There's a $100 prize, there's a $500 prize, a $5,000 prize, and a $50,000 prize. And then there is the probability of each of those values. In other words, you got a 1 in 1,000 chance of winning a $100 prize. You got 1 in $5,000 chance, 5,000 chances to win a $500 prize. The probability of a $5,000 prize is 1 in 100,000, and the probability of winning the $50,000 prize is 1 in 1,000,000. Now, we're asked to create a probability distribution as well as calculate the expected value and then interpret the results. And I'm going to do that on the calculator, except for I am going to just real quickly, since there's not a lot of data in here, do the probability, get my calculator out, probability distribution by hand. So let's say that we've got, let's get two columns here, and we got X and P of X, let's say. So for the $100 prize, we've got a 1 in 1,000 chance. 1 divided by 1,000 is 0.001. For the $500 probability, we got a 1 in 5,000. And that is 0.1232. What is that? 2 out of 10,000 chance. For the $5,000 prize, we got 1 chance in 100,000. That is 1 to the e to the negative 5. So we got 5,000. 1, 2, 3. 0.1234, and for the 50,000, it's 1 in 1,000,000. There's 1, we've got e to the negative 6 value, okay, so 0.123456. Now, expected value, if I were calculating the expected value by hand, I would multiply this 100 by this 0.001, and then I would add it to this 500 multiplied by 0.0002, and the 5,000 plus the 5,000 times 0.0001. I think I said enough zeros there. And then the 50,000 by the 0.000001. And I would add all those together, and that would give me the expected value. Now, fortunately, we have a calculator that'll help us do the work, and I'm going to jump over here to the calculator and create the probability distribution using the list, and then we will do two variable statistic, and we'll see exactly where this expected value is, and let the calculator work for us. All right, well, I'm over here on the calculator. Let me clear off. I'm going to quit what I got right there. And I'm going to take this data, and I'm going to go into stat, and I'm going to edit the list. And I got to clear out what I got in there. Let me clear L2, because I'm going to use both L2 and L1. And in the L1 column, I'm going to enter the prize value. So I've got 100. I've got 500. 500. 5,000. And 50,000. So that was what our prize value was. And now I'm going to enter the probability. So probability of the $100 prize was 1 divided by 1,000. In other words, I got 1 in 1,000 chance. The probability of the $500 prize was 1 in 5,000, so 1 divided by 5,000. The $5,000 prize was 1 in 100,000. And the $50,000 prize was 1 in a million, so 1 divided by 1 million. 2, 3, 1, 2, 3. Okay. And so there is my probability distribution. Now, to calculate that expected value, I'm going to go in here to Stat. I'm going to choose Calculate. And I'm going to choose option 2 here, 2 variable statistics. So I'm going to choose option 2. And it brings up this screen, and I got X list L1, Y list L2. That's my prize value and my probability, and I'm just going to enter through here and ask it to calculate. Now, I get a bunch of numbers. I get the mean, I get the sum of the X squared, so on and so forth, standard deviation and all of that. But I'm scrolling down here until I see this value right here where it says the sum of X, Y, right there at the bottom, and it's 0.3. That is the expected value, the sum of the X and Y variables, X times Y. Think about that, L1 times L2. Every item in L1 and L2 added together, the sum of X times Y in those lists is 0.3. Now, what does that mean? It means that one ticket, if you buy one ticket, your expected value of return on that is about 30 cents. Now, granted, you could win nothing. You could win $100. You could win 500, 5,000, 50,000. But each ticket is worth about 30 cents. Now, if you're the person that's putting the contest together, then you can expect to spend about 30 cents per ticket, depending on how many you sell. But and there you go. So rather than having to multiply and add all those, I can enter them into my list, going through Stat List, and then turn around and run a 2 variable statistic and search down there for the sum of X, because L1 is the X value, L2 is the Y value, the sum of those multiplied together. And that comes, in this case, to 30 cents per ticket expected value, which is the weighted average of the variables applied to their theoretical probability.